Let's open in a prayer. Father, we thank you that you've loved us with an everlasting love. You pursued us and wooed us. Even though we appear to be so small and tiny, yet we are the center of biological life. Even though we're not the center of the universe, yet you've put us in a place that's unique for this purpose, that we could even have this conversation with you and that we can come to know you, whom to know is life eternal. We pray in Jesus' name. Amen. So I'm going to wrap it up now, this material. I'm going to be looking, first of all, I'm going to complete it all with design and astronomy, and then I'll give you a quick overview of the other 5 areas we've looked at before. So astronomy, we're looking at the aurora borealis. How many of you have seen the aurora borealis, the northern lights? It's an exquisite thing to see because it's always shimmering. It's always moving and undulating, and it's a wonderful thing to behold. And it's as a result of particles, ionized particles that are funneled down the magnetic field to the north and south poles. So that's why you have an aurora australis as well, the southern lights, as well as the northern lights, because it relates to the complexity of our Earth's magnetic field. And we're going to be looking at the fine-tuning parameters in astronomy. The universe, however, according to Richard Dawkins, is a very different way of looking at it. He said the universe that we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, and no good. Nothing but blind, pitiless indifference. This is an atheist point of view. And of course, he is certainly one of the premier proponents of an atheistic point of view. This sculpture, this is a good example of that blind, pitiless indifference. It's not exactly something I'd want in my living room or anywhere else, actually. But the point is it just that, or is it something more than that? I'm going to claim that yet another argument, besides all the others we've seen in paleontology, we've seen in specified complexity, we've seen in biology and so forth, all these again show that this is a finely tuned world in which we are. And it's so perfectly fine-tuned that all these parameters have to be in place or we couldn't even be having this conversation. So I want you to have at least a general impression of the rare and unique and complex conditions that are really required for sustaining life and how unique that really is. And it's important for us to understand that in the fine-tuning of the cosmos, that the Earth has a myriad of incredibly interconnected and interrelated life support systems. And the more you look at it, the more you marvel. So science, for me, has become a mode of worship, you see. Just as I use the created order, looking at the beauty that we went through today. And many people don't even notice it when they drive, but it's all around them. You have to have the eyes to see. And attention is a moral act. You have to choose what you're going to look at and acknowledge Him in all creation. Then the beauty of the created order becomes a force multiplier for worship. Because you see, you're looking at the visible, and it points always beyond the mind of the maker, and it's always incredible in every order of magnitude. Well, let's take a look at these factors then. First of all, you have to be in the right galaxy, the right kind of galaxy, and there are hundreds of billions. There's billions of galaxies, hundreds of billions of galaxies, but it needs to be a spiral galaxy. Spiral galaxies get their name from the shape of their disks, in which stars, gas, and dust are concentrated in spiral arms that extend outward from the central nucleus of the galaxies. And so another kind of galaxy is an elliptical galaxy. And an elliptical galaxy looks sort of amorphous or like egg-shaped, and it contains stars having very random orbits, like bees swarming a beehive, you see. And the gravitational pull of these swarming stars makes very unstable planetary orbits, elliptical rather than circular, which in cause would create deadly temperature swings and deadly exposure to stellar radiation. It's got to be just the right conditions. The more we know about it, the more amazing it becomes. And so you're not going to find Earth-like planets in elliptical galaxies either, because most of them don't have the heavy elements that you need. You need to have carbon and nitrogen and oxygen and magnesium and silicon. And these are cooked in the interior of stars from the hydrogen and helium, and then they're expelled into interstellar medium where the stars exploded as supernovae that were needed to form them. And then their third kind of galaxy is the irregular galaxy. And the irregular galaxy, no particular shape, among the smallest galaxies, they have a lot of gas and dust, and they're a very high rate of star formation. And our two sister galaxies, the larger and smaller clouds of Magellan, which you cannot see in the northern hemisphere, you can see them in the south. How many of you have seen the clouds of Magellan, the Magellanic clouds, which are our sister galaxies? You have to be in the south. I still remember having a weird experience when I was in Queensland, New Zealand. I'm 40 degrees south latitude, and I'm seeing a sky that was alien to me. I woke up in the morning, in the middle of the night, and something prompted me to go outside and look at the sky. And I had a weird experience because I was half asleep. And I'm looking at a sky and having an astronomical background, you see. I forgot where I was. And I'm looking, and for a moment I had the experience as if I was in another planet. I felt I was in another world. I'm looking at a foreign sky. It's a Southern Cross, and again, the large and small clouds of Magellan, which are these small, irregular galaxies that are around us. It was a weird experience. It lasted about 30 seconds until I oriented myself. Very strange experience, that. But we are in a perfect condition. Now, it turns out that spiral galaxies compose about 20% of the galaxies that exist. Most of them are elliptical, 60%, and another 20% are irregular. But it turns out that only spiral galaxies provide any safe zone for life-sustaining planets. And the others would not have any place where you could actually have a safe zone, because what would happen is that they would just be too violent, and the galaxies wouldn't have enough heavy elements to contain the Earth and so to construct Earths and so forth. So you have to be in the right kind of galaxy, number one. Number two, you have to be, this galaxy is a particular position in our galaxy as well. So the Milky Way is the top 1 to 2% most luminous and massive of the galaxies, you see. So what we see here is the gravitational mass in our galaxy attracts helium and hydrogen to build heavy elements. And low-mass galaxies can't attract enough of that helium and hydrogen. And there are about 200 billion stars, but little likelihood of life-sustaining planets in our galaxy. You see, you have to be in the right place, exactly right. And so our galaxy is in the top 1 or 2% of the most massive and luminous galaxies. And the bigger the galaxy, the more heavy elements that are going to be there. And so its stronger gravity can attain that. And low-mass galaxies, which make up the vast majority, don't really have Earth-like planets. They don't have enough to construct the heavy elements like the Earth. Then here's an interesting one, and this has only been recently understood, that you've got to be in what's called this gravitational place. There's a specific place, a safe zone, tiny percentage, 4% surrounding it. And here's why. There's a massive black hole at the center of our galaxy. We know this, really the Hubble Space Telescope and others, and almost nearly every large nearby galaxy appears to have a giant black hole in its nucleus. And that's one problem. You don't want to be too close to that. And whenever anything gets near or falls into a black hole, it gets torn up by the strong tidal forces. And so lots of high energy is released, gamma rays and X-rays and particle radiation. And so in our Milky Way spiral galaxy, there are these hazardous giant molecular clouds, as well as areas of high radiation. And they happened, so we are situated in a wonderful place here. We happen to be situated in the place right here where there's a safe zone. It's a 4% habitable zone. You go closer in or closer out, that teeny little circle, you can't have life. You can't have a living planet. And so we are in that safe zone. And I love that, the fact that we're right in the right place where we need to be for this to be. And again, the more you multiply this, the less coincidence begins to be impressive, you see. You can only go so far with coincidence, as you'll see. Yet another one, we have to be in the right kind of planetary orbit. So you have to be in the right kind of galaxy, you have to be the right place in the galaxy, and you also have to have the right kind of planetary orbit. Now, Jupiter's orbit, for example, is nearly circular, and this is important. It goes around the sun every 12 years in a nearly circular orbit. Far out from the terrestrial planets, Mercury, Venus, Earth, and Mars, and most other planets circling other stars, are highly elliptical. Very few are circular, and you need it to be almost circular for you to have the conditions of stability, you see. Otherwise, it's too close in, too much variation. I'm talking about precisely tuned. Things have to be just so for us to be in this condition as it is. And so gravitational pull would upset Earth's nearly circular orbit, you see, and it would subject it to deadly temperature variations. And so it's very important that they have this steady temperature and predictable climate on the Earth. And that's what's necessary within very tight parameters indeed. So the right kind of planetary orbit has to be almost circular, it's elliptical, but very tiny a bit, just enough to where you can manage those differences. Moreover, you have to have the right neighbors in your galaxy, in your solar system rather, you see. It's not indifferent. Jupiter, for example, about 300 times the mass of the Earth, is an important, plays an important role, because what it does, you see, it acts as a shield to protect us from too many comet impacts, among other things. And it actually absorbs or deflects comets and keeps many of them from coming into the inner solar system where it would collide with the Earth and with life-extinguishing consequences. And Saturn and this gravitational pulls then as this shield. And then Saturn and Uranus also have a function of comet catching for us to protect us. It's really amazing. It's really a tough world out there. Yeah, everything seems to be against the possibility of this delicate thing we call life, you see. But everything is in its proper place. As well, Mars and Venus take asteroid hits for us, and we know that the asteroids it turns out to be mostly between the orbits of Mars and Jupiter, where you have the asteroid belts. Here's the backside of the moon, and you see these battle scars, you see, because if you want to get an idea of the asteroids that would probably hit the Earth, you look at the surface of the moon. And so it doesn't have much protection for the Earth, but you can see the hits that you're getting there. But it has to be also, furthermore, the right distance from the sun. Just as you have to be in the right place in the galaxy, so also within our solar system, if you're too close, you'll boil off the oceans if you're too close to the sun. If you're too far, then water and carbon dioxide would freeze, you see. And then it turns out that carbon dioxide traps the sun's radiation and keeps water liquid. And it's very important for us to see this thing. There's a circumstellar habitable zone. And this complex animal life needs enough oxygen, but their conditions to having enough oxygen in the atmosphere are very delicate indeed. The proportions have to be just right for that. You can't be too close, otherwise too much water evaporates into the atmosphere. And it would cause a runaway greenhouse effect, and you boil off the oceans, which is what happened to Venus. If you get too far out, it gets too cold, and water and carbon dioxide then will freeze, and you get runaway glaciation. You see, it'll be over. You won't be able to have life that way. And then the further you go out from the sun, the more you've got to increase the carbon dioxide content of the planet's atmosphere to trap the sun's radiation and to keep water liquid. And so the problem is there wouldn't be enough oxygen then to sustain animal organisms, you see, so you wouldn't have enough for that. And then it's only on the very inner edge of the circumstellar habitable zone where you can have a low enough carbon dioxide and enough oxygen to sustain complex animal life. That's where you are. So it's another tiny little band, you see, very narrow indeed. Just one little bit more, one bit out, and you're not going to have it. And it has to be, as I say, almost a perfectly circular orbit. Everything has to be in perfect position. Oh, did I mention the sun? It has to be the right kind of sun as well. Not any star would do. In fact, only a tiny fraction of stars would fit the bill. And ours is just the one that does that. You see, because it has to be the right mass. It has to be a yellow dwarf. Red dwarfs make up 80% of the stars, and another 9% are called G dwarfs, most of which are less massive than the sun. The sun is a yellow dwarf, and it has to be of this particular type for various good reasons. Has to have one of the things about our sun is it emits a perfect balance of red and blue, which allow photosynthesis, you see. And so its actual radiation is consistent with that narrow spectrum of light that we know. And it's necessary for that to be the case. It has to be the right light, it has to be the right composition, it has to have a high metallicity for creating terrestrial planets, and then as well, right orbit. It needs to be nearly circular around so the sun's orbit in the galaxy, unlike most of the stars, is almost perfectly circular, and that provides a stability as well. You see, the more we're learning about this, the more impressive it becomes. The more we learn it from science about anything of this nature, the more we begin to realize how perfectly suited it really is. It turns out as well that it has to have the right energy output. Our sun has a 0.01 variance on an 11-year cycle. That's it. Very unusual, very stable. Any more or less, and we would not have life. It has to be very narrow. It has to be a bachelor star. Only 10% of stars are bachelor stars. So that when you, for example, see Star Wars or something like that, and you see that on the planet Tatooine that they have more than one star, there's a problem with that. You couldn't have life on that planet. So there's good reasons why that would be the case. It can be a double star or triple star system because the instability would be too great. It has to be really delicate. So only a dwarf, or only a certain kind of star, a bachelor star, which would do. And it has to have just the right luminosity, not too much particle radiation. Again, that narrows the field immensely. It would destroy the atmosphere, you see, and it would destroy the ozone layer as well, so that too much luminosity would cause all kinds of particle radiation, flares and so forth on Earth. And so we have these solar flares, but it's mild enough, and we get the auroras that take place. But particle radiation has the effect of quickly stripping away the atmosphere, and it would increase the surface radiation levels and would destroy the ozone layer. So all of this would be deadly for any life on a planet near, say, a red dwarf. Did I mention the moon? The moon has to be just right as well. And it turns out that there are reasons why this is the case. The moon, you see, this is a large moon, unique in all the solar system, the Earth-Moon ratio. Much different than any other planet, and it has to be just as it is, because what this does is actually stabilizes our Earth's tilt at 23.5 degrees. So we get our 4 seasons, you see, and it's a perfect balance there. And it produces a variation of 1.5% degrees, giving mild seasons that you have. Whereas Mercury, Mars, Venus would have chaotic variations in their tilt. So the moon really does sustain us. It stabilizes our tilt of our axis. It's responsible for our seasons. And so this is another important thing. If it weren't there, then our tilt would wildly range over a large range, which would be wild temperature swings. So if our tilt were like 90 degrees, the North Pole would be exposed to the sun for 6 months, while the South Pole would be in darkness and vice versa. It only varies by 1.5 degrees. It's just exactly right once again. And Mercury and Venus don't have moons. Mars has 2 tiny moons. They don't count for anything because they were apparently little asteroids that were captured, but they're not substantive. So this is unique. In addition to these factors, It increases our tides, you see. So the moon is responsible for 68.5% of our tides and the sun for the remainder. It flushes out nutrients from the continents to the oceans, and this is absolutely essential for there to be life. This process of mixing and so forth, all these materials have to be constantly flushed, and that's why you have these tidal effects and so forth, without which you could not have life. There's a single moon, unique in this respect, because Jupiter has 63, Saturn 33, Uranus 26, Neptune 13, Mars has these two little moonlets, if you want to call them that. But we are in a unique situation. Otherwise, we would have chaotic, deadly tides and seasons, so it's just perfect for that. It also circulates the ocean water, and it regulates the temperatures around the Earth as well. So this is yet another very important factor here that we need. If it was more massive, there would be terrible tidal and rotation effects. If it was less massive, it wouldn't achieve the purpose it needs for actually giving us just the right tilt and the right tides as well. Scientists discovered that lunar tides also help to keep large-scale ocean circulation going because oceans carry a lot of heat, and this is necessary to keep the temperature of the higher latitudes relatively mild. Again, it all works together. You'd think someone was planning this, figuring this out, working on it, you see. And so all these things are fascinating. And then, we also have a core engine that is absolutely necessary. It turns out that radioactive decay helps drive convection of liquid iron surrounding our core. And this generates a dynamo, which creates a magnetic field. If you didn't have this magnetic field, we wouldn't be here having this discussion. You see, for there are a lot of reasons why this is the case. Because this magnetic field shields us from low energy cosmic rays, among other things. And it prevents solar winds from degrading our atmosphere. It's really an exactly kind of perfect system that we have. The radioactive decay from isotopes as well helps drive the convection of the liquid iron surrounding the Earth's core. So you have a dynamo. It creates a magnetic field, which then shields us, as I say, from all these things that would otherwise destroy us. And the solar wind particles would directly interact with the upper atmosphere, stripping it away, especially the molecules of hydrogen and oxygen. And that would be pretty bad news because all water would be lost quickly. So this magnetic field is perfect. And as we know, we recognize that insects and birds and animals, many of them are tuned to the magnetic field and navigate accordingly, as well as by the stars, some of them, and some by the sun's position, some by all three. It's an astonishment there. So then we have the right Earth mass as well. You have to have the right mass. Terrestrial planets must have a minimum mass to retain an atmosphere, you see. An atmosphere, of course, is need to keep basically the good in and the bad out, as it were, to support these chemicals, for the free exchange of chemicals of life and to protect us from cosmic radiation. The planet has to be a minimum size, and it has to be an oxygen-rich atmosphere to support our life. And it has to retain its interior heat from being lost too quickly. So all these things are delicate factors again as well. All these things work together in a combination. So again, Mars, the reality is if the Earth were smaller like Mars, it would cool down too quickly. Mars cooled down and is basically dead. Then this is another fascinating thing. You're looking right here at a partial eclipse of the sun, where the moon covers the sun's photosphere. And we are in the right observation position in our galaxy, because you see we are located between two spiral arms. If we were in the spiral arm, you couldn't see anything outside. We couldn't do astronomy at all. So you have to be right in a place in between where there are fewer stars where we happen to be located in our galaxy. And there's less gas and dust. It offers great visibility, so we're a privileged planet. We are in the right place to look outside and see it. It couldn't be better. And you could go into the details. Just the Orion arm there between the Perseus and Sagittarius. It's just the perfect place in that zone, and also where it isn't surrounded by that dust and gas, so you can look out and see as well. The Earth is the best planet to view solar eclipses. As it turns out, the sun is 400 times larger than the moon. But fascinatingly enough, the moon is 400 times closer than the sun. What does that mean? It means that they perfectly overlap. And in certain conditions, then, you can actually have where we can see a total solar eclipse. And only on a solar eclipse are you able to see the corona of the sun. Otherwise, it would never have been visible. We learn much about astronomy and the sun's nature from that. So it's just a perfect place. Again, everything seems just right. What's the probability of 200 finely tuned parameters occurring by chance? And it's not a good number, you see. And we're being very generous. And we're estimating something like 800 finely tuned parameters. The number keeps going up. Because you remember when Contact came out, and Jodie Foster was in it, and the claim was made, all those galaxies and stars out there, what a waste it would be if we were the only one. The problem is, it appears from what we now know that it took a cosmos of this size and nature in order to create the conditions where we could be seeing this. And frankly, it's so finely tuned, you're not going to have another one out there. That's an amazing thing. We are the privileged planet, and the fine-tuning parameters are so great that nowhere else would there be life, in spite of the fact. But what of all these millions of exoplanets? Fine, but none of them are in the conditions that are even remotely close to what we would need for the life itself. So there may be the probability, maybe 10 to the 20th, I'll be generous with these kinds of planets, but it would only reduce the probability by a small degree. Instead of 10 to the minus 215, it'd be 10 to the minus 195. It's not a good number. So you're talking about, for example, when looking at the chances, to get heads 50 times in a row, it would be one chance in a million billion. Now to get, I'd say pretty well, not a chance. Then when I see this number here, and again, we're being extremely generous and conservative about this. It turns out being generous, the probability is so low. It's 10 to the minus 215, so you have 215 zeros behind that thing. It's not a good chance. In fact, anything more than 10 to the 50th, forget it. It's virtually impossible. But then there was this infinite universe as answer to fine-tuning. You see, because what happened is it's evident that we're in a Goldilocks universe. It's evident that we're in the right place for this. And so the supposition is, well, we just happen to win the cosmic lottery. So multiverse theory has been propagated and increased, but it's a mathematical construct, but it doesn't have any actual empirical warrant at all. Furthermore, if you analyze it, these infinite numbers of universes would actually not work for a lot of reasons, because you see, they would, among other things, there'd have to be a fine-tuned universe-generating system to create the conditions that you're trying to explain away. So here, why is it so finely tuned? Well, it turns out that to even have a cosmos, a universe to be formed, would require a fine-tuned system. So it's like saying life probably didn't exist. Many people have given up on the idea of life existing on Earth, evolving on Earth. It's virtually impossible by just time and chance and the impersonal. So they now, many say, panspermia. It was actually brought from outside. You see, extraterrestrials or whatever, it was formed there. What's the problem with that argument? All you're doing is pushing it back one further. Where did that come from, is all you're doing. Same with the multiverse. Even if you had a perfect generated system, what created the system, which it has to be fine-tuned in order to create the system you're trying to explain away what that is fine-tuned. It doesn't work. You're pushing the problem back one further. It's a desperate effort in many respects, because they're actually denying the first and second laws of thermodynamics in many respects in embracing this idea. But people will be desperate because it has to do with the apparent anthropogenic system here, the anthropic principle, that it appears that we're on this planet it's a privileged planet for a good reason. So the way it's trying to explain it away, though, doesn't work. So it doesn't. This answer to fine-tuning doesn't work. So I'm going to give you a bit of a summary, and then we can see if we have any extra time here. But I want to give you the 6 things we've looked at. And again, remember, these are all available on the website. And so I just call this to your attention here, just in case you don't know this, because a lot of people don't know. It's kind of interesting. If you go to what's going to become reflections.org, right now it's still kenboa.org, but I'm going to change it to that. If you go, you see the weekly studies tab there. And the weekly study, there are 3 studies a week. And the Sunday morning study that I've just touched is here, and you can see where we are. So you can go back and you can see the intelligent design images there, and actually play the video, and there's a little description as well. You see that? So you can always go back and see any of these previous series. I'm just calling that to your attention. So in terms of the 6 things, the first things we looked at was what was called irreducible complexity. Evolution, by definition, it makes the whole system break down because effectively Darwin's whole system was based on what he called numerous successive slight modification. The problem, though, is that they all have to be, it's all or nothing. They all have to be there at the same time. All the components have to be there, otherwise it will not work. So that we see that intelligent agents can produce information-rich systems, but we know at present there's no natural explanation or natural cause that can produce information. Surely not natural selection and mutation. Mutation doesn't generate information, it reduces information. It actually is not beneficial at all. And time is not your friend at the end of the day. It turns out that the systems have to be in a certain time frame, and there's limits in how long they can work for catalysts to take place and so forth. The reality is that you have to have something that brings it together all at once. We also looked at biochemistry, and we're talking about these intricate molecular machines that are irreducibly complex, like the bacterial flagellum. And again, evolution, by definition, can never account for the existence of these systems, all of which have to be boom, 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 one after another. All the pieces have to be in perfect synchrony, in a perfect sequence as well, and working in that way. So again, it cannot account for that. When we looked at specified complexity, we saw that information-rich sources belie their intelligent cause, and that Darwinism is incapable of accounting for the origin of information. So when you're looking, for example, at the nature of your biology, your systems, your DNA, it's specified complex systems that are rich in information, but information comes from a mind. It cannot. There's no information that's formed randomly or chaotically in that respect. Then you have genetics. We looked at genetics, and it uncovers the highest levels of information in the universe. These information-rich biomacromolecules that we see. And again, complex information cannot originate by chance or natural processes. Remember, we talked about the probability of getting 4 words of 4 together. Each is 4 words, 4 letters each. And it was the perfect conditions, maybe 12 seconds. Then the second word took about 5 days. Third word was about 100 years. And then I had fun with you trying to get you to bid up for the 4th word, which only had 16 letters. And I bid up, and you wouldn't buy it because it was so big, you didn't think it could be that big. 100 billion years to get that. And then if you figure a 5th word, so you're not even going to have a Shakespeare's Tempest. You're not going to have a fifth, you're not going to have the first sentence. To have 5 words, 20, it'd be in the septillions, you see, by that time. It just goes up exponentially. So again, it can't originate by chance. We also saw that paleontology shows abrupt appearance and stasis. The fossil record that we see in the sedimentary strata is always abrupt appearance without forebears, number 1. Number 2, stasis. They don't change. And that's why we have these living fossils. We thought they were gone hundreds of millions of years ago using that time frame. But no, they're still around. They haven't changed a bit. And then extinction. That's the fossil record, which is consistent with what we would say. Whereas Darwin said, she can never take a sudden leap, but must advance by short, slow, and sure steps. But that's not how it works, you see. And so the Cambrian explosion revealed all these body types and plans overnight, as it were. So it doesn't work. And then we saw with astronomy that it reveals the amazing fine-tuning of the universe, which is a byproduct, a product of intelligence. The finely tuned parameters is impossible for us to grasp. So therefore, my summary, again, I go back to my little pal, my turtle on the fence post, because the three options, of course, is necessary. It had to be there. The natural laws like gravity demanded to be placed on you have to be a madman to believe that. Or you could say a tornado blew it there, possibly. I wouldn't put my money on it, and nobody with common sense would do that either. It doesn't happen to be plopped right on top of that. And instead, somebody put it there, so there's an intentionality behind it. And so the interesting thing is why then isn't intelligent design widely published? Well, there's a problem, as we know, in the academic realm of censorship for dissenting opinions, which is unfortunate. That instead of hearing two sides, it becomes this oppression of a narrative that is science by consensus never produces good science. You see, so you have to realize, though, other perspectives need to be seriously taken into if there are good arguments for them. Scientific journals have referees who eliminate any papers which would even hint at a design or a designer. And there is a kind of an industry that is generated by this, in which but on the other hand, thousands of competent scientists now are in that camp and growing, a growing number of them, including geologists and astronomers and so forth. And furthermore, there are extra-scientific implications of this. There are metaphysical issues, and that's what it comes down to. You're dealing with God, you're dealing with your meaning, you're dealing with your purpose. This is not just indifferent. This has to do with metaphysics. And so science has been, unfortunately, conflated with scientism, a materialistic worldview. That is not good science. It's not scientism. It should be open to the possibility of it could be chance, but it could be design. And that to eliminate that is a mistake. The ones who oppose the theory of design most vociferously do so for religious reasons. Michael Behe writes, and I think he's quite right about that. And that's why Darwinism tends to be off limits for criticism, because it's something that will not, because of its metaphysical implications. So it's kind of a sacred ground. And so when I weigh the evidence then, I look at this chart, and I compare, on the one hand, what would you plump for? Intelligent design, which tells us that the effect is not greater than the cause is greater than the effect, or that the effect is greater than the cause. Because last time I checked, that no design is inferior to design. Mindlessness is inferior to mind, and so forth. So the whole proposition then is, even common sense shows us more and more that the evidence would show that the evidence points to the effect being always subject to the cause, and so a greater effect. Mind produces mind. Designer produces design. Someone who has intentionality, life produces life. Purpose produces purpose, and so forth. And so as I see that, then my conclusion is that the momentum of the empirical evidence will predictably continue to grow in the direction of elegance, complexity, and information. I can promise you that. Not a guess. Even since I did this presentation 10 years ago, very little needs to be changed. In fact, if anything, there's more evidence, and far more evidence in support of it. So I can predict that the more you learn about anything, the macrocosm, the microcosm, the midicosm, it'll always be the case that you'll discover things you didn't even imagine, you didn't know enough to know, to ask. And it gets more elegant, not less, as we go along. Secondly, the neo-Darwinian account of naturalistic processes is already hopelessly outmoded and inadequate in its explanatory power. That's becoming an embarrassment now. because you see you have a system that's been out of date and not effective for many decades now. It just doesn't work. And the increasing evidence only makes that more obvious. And the increasing momentum of evidence will only make this inadequacy even more obvious with every passing year. These are some of the books that I used at that time. Evolution, a Theory in Crisis by Michael Denton, Darwin's Black Box by Michael Behe, Intelligent Design by William Dembski, The Design Revolution by Dembski, Icons of Evolution, terrific book, A Case for the Creator, another great book by Lee Strobel, Darwin on Trial, and The Privileged Planet. All these are great. There are lots, can you imagine what's come out since then? A rich array of things in each of these fields. But it's wonderful to see that God has not left himself without a witness. Oh, we always have this little thing, reflect. If you're not getting this, sign up, go to the Reflections, thekendor.org, and get the email. There's a daily growth email, and there's a teaching letter. I fear that I'm out of time. I went too long. I didn't even give you any time for questions. I didn't intend to do that, but there you have it. But we're going to go to an entirely different topic now, and it's going to be related to loving well. We're going to be talking about the spiritual life, and so I like to bounce it around, do short little series, and then we'll do something about living well at another time. Let me close in a prayer. Thank you for that. Good man. Before I close in prayer, then, again, some of you came in afterwards. We have copies of Handbook to Prayer for everyone here. So please grab one out there and it's on a 3-month cycle. This is month 1, day 2. As I said to the group earlier, if you miss a day or 2 or 3 even, skip ahead to that day. It'll always be easy to know because you know when you're in month 1, 2, 3, and then it'll be back to month 1, and you know it's the calendar date. I'd love it for us to do that. So take your copy of it and then start it today. So that this is month 1, day 2. Just go through that. And what? This is month 1, the first month. Yeah, the first month. October is the first month. That's how we're looking at it. And it makes it real easy, no guessing. And so grab a copy of that. Lord, we thank you for this time together. Give us your guidance, your encouragement, your perspective that we could love you well so that we trust the Father, that we would abide in the Son, and that we would walk by the Spirit. Pray in Jesus' name. Amen.